we are doing this, the purpose of doing this is basically to kind of convince ourselves that the stuff we have learned, we can build like really cool stuff with it already. So I hope you will enjoy this. I am also pretty excited. Cool. Can you all see my screen?
Yes, sir.
Okay, great. So yeah, like coding is not just about learning syntax, right? So we should also learn how to think and how to express our thoughts in code. So first of all, let me introduce the game since we may or may not have played it. So basically, this is the game we are trying to build today. Um, like there are two players, one on the left, another on the right, and there is a ball that moves around, and you have to catch it. If you miss it, then you lose a point, basically. So this is like ping pong is like TT, simpler version of TT. Cool. So we'll start thinking about the problem, right? Like how should we break down the problem? So first thing we want to do is probably, okay, let's start with our basic setup. Okay, so we want to probably, I think, draw a grid, right? Then we want to maybe move the ball. Then we want to figure out how to move the pedals. And then we want to check who won the game. So in some sense, so we are doing like a simpler version of it. Like we are not doing the points thing. As soon as someone misses the ball, that player loses. So we essentially need to do these four things, and we would likely want to do it in a while loop, right? So we constantly draw the grid, we constantly move the ball, we constantly move the pedals, and so on. And if there is a winner, then we stop, right? So there is some if condition here, and if this is true, we kind of, yeah, we basically just stop, right? So this is like high level what we want to achieve. Uh, so the reason I introduced this is because so in coding sometimes like when the problem is too big, you want to break down the problem into smaller parts and just to do the smaller parts first without worrying about the overall end-to-end thing, how you want to approach it, because this is a bigger project. So we are breaking it down into smaller things. And next, so let's first draw the grid, right? So let's say, and the nice thing is now that we have learned functions, we can start using them. So let's say draw grid is a function. So which basically draws the arena. So let's say this is a 2D array. Let's say it's how big is my screen? So I think, yeah, something like 40 rows should be fine. And something like 140 columns is probably okay. So we define a grid of row size and column size. Then then so it will be nice to draw some boundaries, right? So we know where the boundaries are. So I'm gonna draw dot 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 on the top, then dot 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 on the bottom, and same for left and right. So to do that, I can just loop over the row size. Let's just call it R. Okay, so I am looping over all the rows. So what do I want to do? I want to change the first 12 dot, and I want to change the, yeah, is there a question so far? Guess not. I'll do the same for columns. Okay, and then I can print it out. Right. Or I can maybe print it as a string. So in that case, I should also null terminate the string. So let's increase this by 1, so we can use the last bit for null termination. And then we can print it. So let's run this program, see what happens. Okay, this is complaining that I didn't return anything, so I'm gonna make it void. Okay, something went wrong. We didn't put a new line character, and then there was also a lot of noise, so we should actually put spaces in everything else in the grid. So
Can you please increase the font size?
is this better? Okay. Cool. So I think this should work now. So basically, yeah, let's try it out. Okay. So this is drawing like an empty rectangle over and over again. Cool. Okay. So next, let's define a ball, right? We want to move the ball around. So let's say this grid also takes where the ball is, and it takes the ball's coordinate.
Sir?
Yeah.
So here AR calls it SZ, the last one. So here why 0 and not null character like /0?
Yeah. So is the same thing like null character in ASCII value. If you look at it, the value of it is 0.
Okay,
So this is basically doing the same thing. Yeah.
Okay.
Yeah. So now let's also draw the ball. So we are saying a ball R, ball C is, let's say our ball is star, right? So wherever the ball is, we'll draw a star. And let's say initially the ball is at midpoint. Okay. So actually, let me open another terminal here. So I can do pong.c.
So it is made.
And a dot out, right? So I'm going to run this code with the ball. And it is printing over and over again. So the ball is not moving yet. It's in the middle of the grid. So this is printing too fast, right? So let's slow it down a little bit so we can see what is going on. So to slow it down, what we can do is we can use a function called sleep. So sleep will basically pause the program for, since I said 1 here, it will pause the program for 1 second. Then it will go again in the while loop. Then it will do draw grid, and then it will pause it again for 1 second. So basically we are drawing the grid, a new grid every time after 1 second. So let's run this again. Okay, so it's actually drawing it. Yeah, so it's constantly drawing it, but now that we have slowed it down, we can actually see the screen being more stable. Okay, cool. So any comments, questions? Is this good so far? Like what we did here? Or if someone joined late and they are lost, what is going on?
Sir?
Yeah.
So can you please again explain how you made all the boundaries?
Yeah, so basically this is a 2D. We are storing this as a 2D array, right? This whole boundary is a 2D array.
Okay.
So sorry, the whole grid is a 2D array. So what do you want to do, right? You want to make the all the columns in the first row as dots.
Yes, sir.
Then similarly, all the rows in the first column as dots.
Yes, sir.
And then same for the other two boundaries. So basically what we did is here we loop on all the rows. Then we make the first column as dot. So this got us
Okay.
the left boundary, right? Then by doing this, then we said, okay, I'm going to put the right boundary as dot. So this got us the right boundary.
Okay.
Yeah, it's a good question.
Sir?
Yeah.
Why did we require that line AR column size equal to 0?
Yeah. My tab is not working. What happened? Yeah, so this is for null terminating the string. Remember when we print a string, right? When we are using %s in printing, it will basically keep printing until it sees a 0. So if we don't null terminate the string, then it will actually keep going and print like garbage even. So let's check it out. So I remove the null termination, and let's see what happens if I run it again. So the printf is now confused, right? So printf doesn't know where to stop. It will, yeah. So that's why whenever you print a string, it is important to null terminate it.
So, sir, after each row, it sees a null terminator and it goes to the next row. Is it like that?
In each row, yeah, exactly. So in each row, we are first setting the left boundary, then we
Yes.
set the right boundary, then we null terminate it. Then in the for loop, we come down. Set left, set right, null terminate, come down, and so on. So this one is setting the top boundary. This one is setting the bottom boundary.
Sir, increase the font size.
Okay. Cool. So I hope this is clear. Any other question with the grid? Okay, great. So now let's start.
Sir,
Yeah.
why we are taking a ball also?
Okay, yeah. So basically, this is the game we are trying to build, right? So just by drawing the grid, it's not that interesting. So we want to move the ball around on the grid as well, right? So what this is doing is just tell me where the ball is, and I will draw the ball wherever the ball is. So now the draw grid doesn't care where the ball is, right? Or how the ball is moving, how the pedals are moving, and so on. You just tell it where the ball is and it will just draw the grid for you, right? So we have like split our work by creating this function. So currently we told this function that the ball is in the middle of the grid, right? So that's why when I run this, the ball is just stable in the middle of the grid. And since we have not started moving the ball, it's pretty stable here. So every time it is in the middle of the grid. I hope that answers the question. So why we have the ball is because the game has the ball, right? So cool. So we can move to the next part, which is let's start moving the ball. So to move the ball, we need to have a concept of velocity. So let's say so every time, let's say the ball will move by one step to the right and then one step to the bottom. So we are increasing. So the dr or like differential of row is 1, and let's say differential of column is also 1. So what we are going to do is in the loop we'll say every time the ball basically moves by once by whatever the dr is, and similarly the columns moves with whatever the differential of column is. And we also need some boundary conditions, right? So if the ball is moving, it may go out of the grid and our program will crash, and we can actually try it. So if I run this, yeah, so the ball is now moving. Let me reduce the sleep because this is going to take forever. Let's reduce. So instead of, so sleep takes a number of seconds, and U sleep is taking number of microseconds. Micro is like U. So let's say we want to move it at 30 frame per second. You might have heard of this, like our movies and games are like 30 frames per second, right? Or it's also written as 30 FPS. So this becomes 1000 upon 30. So roughly 33 milliseconds. So we are drawing a new frame every 33 millisecond, right? So that's what we will use here. So I'm saying let's sleep for 33 milliseconds. So after every 33 millisecond, it will draw a new frame. And you might have studied this in physics actually. So currently when it is sleep 1, we can see the ball jumping around. Like we can see this gap. But the reason we pick like 30 frames per second is because our eye can works at like 16 1 by 16 seconds. So if something is moving faster than that, then we think that it is continuous motion. So like if we run this, now it feels like the ball was moving continuously, right? And since we don't have a boundary condition, it basically goes out of the array and it crashes with a segmentation fault, right? So I think this is too fast actually. Let's slow it down.
Sir?
Yeah.
So how did you manage to make that condition that if it goes out, then the program crashes?
So I didn't make that condition. This is actually the thing about C. So what is going on is like in a array, like if the index of the array is greater than the size of the array, so then basically it will crash, right? That is segmentation fault. So since we didn't put any boundary condition, ball R and ball C will be eventually greater than 40. So I think ball R is, let's say, 41 and ball C is also 41. So then this will crash because it will try to set a value outside of array. Right?
Okay, yes, sir.
So I didn't make that condition. This is just the nature of the language. Yeah, so as soon as the ball goes out, it crashes. So we should add some boundary conditions so that it doesn't crash actually. So what are those boundary conditions, right? And actually, yeah, let's add the boundary conditions first. So if it is trying to be less than 0, then we are saying that don't make it less than 0 or like force it to 0. If it is trying to become greater than row size -1, then we say keep it to row size -1. And similarly, if our column is trying to be, oops, column is trying to be less than 0, then we force it to 0. If column is trying to be greater than col size -1, then we force it to col size -1. So this is now our boundary condition. This will make sure that the ball never goes out of the grid and crash the program. So now if we run this, the ball keeps moving and then it is stuck there, which is interesting. And then it is finally stuck at this point, right? So why that is happening is, right, like, so the row hit the bottom and then we said it cannot move any further, so I'm going to fix the row, but the column is still moving, so that's why it kept following the lower boundary, and then at the rightmost corner, right bottom corner, it got stuck. Right, let's look at it again. So it keeps going down. The row is forced at the bottom boundary, but the column is increasing, and then now both row and column are stuck. Cool. So that makes the game boring, right? So in the actual game, what should happen is some kind of a reflection. So when it hits the boundary, it reflects and comes back, right? Right. So let's do that. So what do we want to do, right? So basically, when it hits the top, then we are saying that I'm going to reverse the direction, and I'll reverse it by multiplying the velocity by -1, right? So this should reverse the direction of the ball. Okay, so let's run this again. So this is, we basically just coded up a law of reflection here, and we can think about that in a bit, but let's first run this and see what happens. So it comes down, hits, then it reflects and starts going up. It hits the top, then reflects, then it hits the right boundary, reflects, and so on, right? So now the ball is moving around in the grid.
Sir, the angle at which it hits is always fixed, right? It's like always 45 degrees, isn't it?
Correct. Yeah. So exactly. So basically our dr by dc is the angle. The velocity is, yeah, so our angle is dr by dc. So since we are multiplying it with -1, we are not changing the angle. So we can play with this a little bit. So we can, let's say if I increase the DC to 2, so let's see what happens. Now it should start moving in a different angle. So as we can see, it's moving more on the column. So we change the tan theta to 1/2 or something. So previously it was 1, now it is.
Sir, but the reflection laws are still the same. That if
Correct. Yeah, reflection laws are still the same. So yeah, like once we build the game, we can play with this more to make the game more interesting. But I think for now, this works for us. Cool. This is fascinating to watch. This is nice. Great. Great. Yeah, this is pretty awesome. Yeah, any questions so far? Like what just happened?
Sir, is there only one grid or many grids? Is there only one this square rectangular grid or there are more than one grid? Because we are running the while loop for infinite times.
We are creating the illusion of motion, right? So that's how actually movies and games, everything works like that. So things are not actually moving. It's just a one static image after another. So if you just move them really fast, you feel like the things are actually in motion. So if I scroll up, it's basically drawing this grid over and over again with slightly different location of the ball, right? But because we are moving it super fast, it feels like the ball is moving constantly. It's giving us the illusion of the motion because our eyes are built that way.
Sir?
Yeah.
Isn't there a command in which we can overwrite the original screen?
Yeah, we can. But yeah, we will do that. But currently, I think this is good enough because we have set the size in a way that that the previous grids are not interfering with our view here.
Okay.
And we are able to scroll and look back on the previous grid to understand what is going on. But yeah, later when we have built it all out, we can put that in and clear the screen every time. Cool. Any other questions, comments? This is fun to watch. Okay, great. So let's start with adding our players. Right, so these are the two paddles that we want to add, right? So let's start with adding two paddles. So I have a paddle 1, let's say. So paddle is moving in the same vertical axis, right? So I don't need both column and row. I only need its row to figure out where the paddle is, right? So I just need a row to figure out where the paddle is. And let's say it starts in the middle of the screen. So both the paddles start in the middle. And I have to now tell the grid to also draw the paddles. So grid also takes two paddles. And after drawing the ball, it says I'm going to start at this row And let's say our paddle has a constant length. So paddle length is, let's say, something like, let's say 7, right? So so instead of going all the way, I'm going to go to an R plus paddle length, right? And then I'm going to say that let's say the first player is represented by 1 and the second player is represented by 2, and second player will be so the first player is on the left hand side, so just before so 0 is the left boundary, right? So that's why we put a 1, so it's right next to the left boundary. And so player 2 is right next to the right boundary, so right boundary is call size -1, so I need to draw it at call size -2.
Sir, sir, the first line is for the boundary, then comes the paddle, then comes the number. So should it be R comma 2?
R comma 2. Okay. So 0 is our boundary, right? What is at 1?
Sir, at 1 there is the paddle of the player.
Yeah. So we are drawing the paddle here itself. So this is
Okay.
that. Yeah. So this is the paddle. Yeah. Okay. So now if I run this, we should see 2 paddles. Yeah. So there's one paddle here, another paddle there, but they are not moving. So that is fine. But yeah, the paddles are working. Great. Any questions? Because I feel like we are moving quite fast. If I'm happy to slow down, if there are any things, there are some things which are not clear. Yeah.
Suggestion, could we increase the clearance between the paddle and the boundary? Because now it looks as if it is merging in the boundary.
Sure. So let's do that. Let's say has defined paddle margin is let's say 3. So I'm going to draw this at wherever the margin is. Okay, great. So it is a little bit forward from, yeah, little bit inside from the boundary.
So the 99,000 milliseconds that you said, so how did you determine that the others are becoming like difficult?
Yeah, so so generally, so for our eyes, like anything faster than 1/16 second, faster than 1/16 seconds, feels like motion. Right. So if my sleep, if this thing is, let's say, let me make it 1 second. So if I make it 1 second, then we will start feeling a little bit of jerk. This doesn't feel like 1 second. What happened? Okay, this is 100 millisecond. So if it is like 1 second, then we don't feel the motion, right? We feel like ball is jumping. So then what we did is we wanted to speed it up. So generally the games are written in what is called like 30 frame per second. So that means every second it is drawing 30 frames. So 30 frame per second means there is new frame every 33 millisecond. So next we did that, but we found that it is too fast actually, because yeah, so the ball, we see the motion, but the ball is just too fast now. And the reason the ball is fast is because our this grid is actually really small. It's just 40 by 140. And if you think about your screen in terms of pixels, that is like a really big grid, right? So because we have a small grid, this feels like very, very fast. So that's why so that's why I just randomly increased it to multiplied by 3 to slow the ball down a bit.
Thank you, sir.
Yeah. Cool. I think I should explain the reflection bit a little bit since we didn't cover that. So actually, let's see, law of reflection. Right. So this is the law of reflection we must have all studied in 12th or so, right? So basically, there is incident ray, and what the law of reflection says is this angle is equal to this angle. Angle of incidence is equal to angle of reflection. So what we did is when it hits, so in other words, basically when it hits a boundary, so if your velocity in this direction remains the same, so this is a vector, right? We can break it down into two components, in the horizontal direction, in the vertical direction. So if the horizontal direction velocity stays the same, and if we reverse, so vertical is down, if I just reverse down to up, then basically the angle remains the same. So the horizontal velocity is not touched, but the vertical velocity is reversed. So when we do that, that makes the angle to become the same, because the angle is really the like tan theta is the ratio between the vertical component and horizontal component, right? So that's why when we hit a boundary, we just multiply that particular component with -1, and we don't touch the other component. So in this case, like ball DC remains the same, right? So just by doing this, we have implemented the law of reflection. So all our boundaries exactly reverse the direction in one direction and keep the velocity in the other direction the same, right? So that's why this motion feels more natural. Like if I were to change it, let's say if I were to multiply with -2, for example, then this motion will start feeling a little weird. Let's see. So if yeah, see how the ball went like, oof, oh my god. Yeah. Yeah, so basically the angle at which it is going, we want to continue the same angle. That's why we multiplied it with -1. So the motion feels more natural.
Sir, in this case, sir, why did the velocity increase? It kept on moving faster and faster when
Yeah.
you did it to -2.
Right. So what -2 is doing is basically it kept this direction the same, right? But it increased the magnitude of this direction. Sorry. So there is
So
a
like it,
horizontal.
from 1 it became 2, then 4, then 8,
Exactly.
like that.
Exactly. So your overall velocity is r square plus c square, right? So your
Yes.
vertical and horizontal component. So if you are keep increasing one component, your overall velocity is going up, right?
Yes, sir.
Okay. Any other thoughts, questions, comments? Great. Okay, cool. Okay. So we should change this a bit now. So basically, only when it, so currently, even though pedals are not moving, this game keeps on going, right? But in reality, when the ball hits the left boundary, actually this player loses, right? And the game should stop. And if the ball hits this boundary, then the game stops and the left player wins. So, and the ball should reflect only when it hits the paddle, right? It shouldn't reflect on the left and right boundaries. So we can do that. So basically, if the ball is ever less than equal to 0, this means actually the player has lost. So we are going to say printf player 2 wins. And then we are going to just finish this program. Actually, this is column, not rows. And when it hits the right boundary, I say player 1 wins, right? And finish the program. Okay, so let's run this. Let's run this. So it went here and called out that player 1 wins, but actually it should have reflected from the paddle. We have not added that logic, but basically as soon as it hits a left or right boundary, it stops the program. So now let's add the reflection from the paddles. So if it hits let's say so if it hits, then we are going to say right, and then we are going to multiply the velocity by -1. So see, like, this is the beauty of functions, right? So I am not thinking about the logic on how we will figure out that the paddle hits the ball. I just think that there is a function which will take care of it. I don't really want to think about it right now. So I will just assume there is such a function and continue coding. So I can kind of focus my thoughts. And then similarly, if paddle 2 is hit, I want to make sure that the ball is on, where is it, call size -1 minus paddle margin. And I will reflect this, right?
So what you are doing with this call size -1 minus paddle?
Yeah, so what might happen actually is like we don't want the ball ever to go behind the pedal. So if there was a hit, we will just force it to, this is like a boundary condition for the pedal, like the ball doesn't go behind it. So if it hits, we will just continue the ball from here, right? Okay, so now let's write these functions. Int paddle 1 hit, it takes a ball location and it takes a paddle location. Similarly, we have a paddle 2 hit, it takes a ball location and a paddle location. So when does it hit paddle 1, right? Does anyone want to help me write this? When does the ball hit the paddle?
If column is equal to margin.
Okay. So if our column is, so the ball should have made it to the paddle. If the ball is anywhere before this margin, then it has not hit the paddle. So if it is greater than the margin, then we can just return false. Okay. Any other condition? So, but the paddle, it may hit the margin, but the paddle may be under it, right? So we also need to consider the row. So I can say if the ball row is less than paddle low, then I'll return false. Or if the ball low is greater than paddle low plus paddle length, then I'll also return false. Otherwise, I'll return true. So basically, so this is PR is the top half of the paddle. If the ball R is less than PR, that means it hits somewhere above the paddle, right? So we will return false. And PR plus paddle length is the bottom of the row or bottom of the paddle. So if it hits anywhere under it, then we will also return false. Okay, so this should be fine. Similarly,
Excuse me, sir.
yeah.
Sir, when we like in the main loop where we've checked the if conditions, shouldn't we reverse the direction of motion there as well?
Yeah, so we do that. So if the
okay.
Yeah.
Sorry, I didn't see that.
No. Yeah. Okay, great. Let's write the same function. So the only thing we need to change here is if the ball is before the right boundary. So if my paddle is, sorry, if my ball's column is less than col size -1 minus paddle margin. So if it is less than that, then I'll return false. So this should work. Let's see. Line 111. Okay. Okay, exciting. Ah, shoot. What happened? Something crashed. What happened?
Sir, I think after the if it should be ball C equals paddle margin. Because the column should be there, not the row.
Thank you. Yes. You saved 10 minutes of the class for debugging. Okay, great. So now it is reflecting from the paddle. And if it doesn't hit the paddle, then it stops the game. Why did it stop here? It should have gone there, right? So let's see. What did we do? We said if the ball C is less than equal to 0, then we will stop the game. But we actually did not draw the paddle. Sorry, draw the ball. So we should draw the ball. How to do this? So if you follow this, right? Like, so it shows that the ball is here and it already stopped the game. It would have been nice if the ball was here, like on the boundary. Right? So to do that, what can we do?
Can we use some time function? After some milliseconds, it prints out.
We can remove equal to, like ball c is less than 0.
Yeah, that would work.
Let's try that out. I think it might give us issues at some point, but let's try that out. Let me increase the speed since we are not playing right now. Okay, yep, this works. But I think I am not a big fan of this approach because so if we were using a different velocity, let's see, if the ball R was on 2 and yeah, it may produce a crash. So ball DC is 2, right? So what may happen is ball C is 1 and then it draws at 1 and then it subtracts 2. So ball C is now -1. Okay, yeah, it will not crash, but in that case, we will not see the ball at boundary as well because we'll just see the ball at 1. Yeah, this is fine. Let's move on. It's not a big concern. Okay, great. So far, so good. Our game works. We just need to move the paddles. Cool. Any questions, thoughts so far? Are you following everything that we are writing here? Okay, great. Okay, so the final thing we have to worry about is moving the pedals. And this is the tricky part. So I'll say, let's say, so we'll see the problem with scanf in this. So let's say I have a character and I want to get a character from the user, and scanf doesn't take this, right? Oh man, I'm forgetting scanf syntax. Okay, so I think this is the right one. So then we are saying if the character is W, then we are saying move paddle up, move the first paddle up, right? And if it is S, then move the first pedal down. If it is I, then move the second pedal up. If it is K, then move the second pedal down. Right, so again, we are using the beauty of functions. Like I have not written down this. I don't know what is going to happen in this, but I just assume there is such a function and I created my logic without breaking the flow. So this is great. And now I can go and write this function.
The scanf and C will work. Percent C we don't need.
Yeah, I'm forgetting this syntax. I don't know why. Is it like this?
Yes.
Okay. Yeah. Scanf. Wait, scan. This is like Python and everything is getting mixed up in my mind right now. Okay. So now let's say we want to move the paddle up and it takes the position of the paddle. So what it does is it it reduces the row and we also check the boundary conditions. So if it is less than 0, then we force it to 0 and then we return this. And similarly for moving the paddle down, I'm going to increase the paddle and I'm going to check whether the PR plus paddle margin, no, paddle length should be less than or equal to, or if it is greater than, call row size -1, then I'll force it to row size -1 minus paddle. This looks okay. And then here I'll say whatever it returns, I'll assign it back into P1R. Whatever this returns, I'll assign it back into P1R. Okay, great.
Sir?
Yeah.
Sir, what is the function returning? Move paddle up, move paddle down. What is it returning?
It's returning the new position of the paddle. So it changed the. So we give it the old position and it returns the new position.
Okay.
Right. So we give it the old position and we put whatever is the new position, we put it in here. And similarly this. Okay, I don't think I made a mistake here. So this looks okay. Cool. So now if we run this, this will have some issues. So the problem is the ball is now not moving, right? Because it is stuck at scanf. It is waiting for user input. So I press W and press enter. Let's say I keep doing this. So we can see the paddle is moving up. And if I do S, then the left pedal is moving down. S, enter, S, enter. Similarly, if I do I, the right pedal is moving up. And let's see if the boundary condition is working fine. Oh, player yes. Okay, let's check if the boundary, so I'm moving the left pedal up. Okay, so now it is stuck at that boundary. So, but it crossed this boundary. So let's fix that. So instead of less than 0, we should say less than 1. so that it is under the boundary. And similarly here, we should say if it is row size -2, then I'm going to do row size -2. Okay, let's try again. So I'm moving the paddle up, up. Okay, it is stuck there, right? So our boundary condition is working fine. Then I move my paddle down. I think this game is going to end. I'm going to miss the ball. Okay, try again. Move the paddle down. It is stuck too early. What did I do? So this should be row size -2 minus pedal length. Okay, so since we're not drawing pedal length, okay. I see. So this was okay. Because we are looping only till pedal length -1, right? When we draw the pedal, we are not looping to pedal length. So if I go down, okay, so now this is fine, right? Cool. And because this is the another nice thing about functions, so I don't have to check my right pedal because they are literally using the same code. So I know that the right pedal will work fine, right? Cool. So the game is working, but it's not a very fun game because the scanf is forcing us to wait. Right. Okay. Cool. Any questions, thoughts so far?
So why did you take case WIJ like this?
Just for convenience, you can take whatever you want, but W is up, so I move it up. It's on the left hand side, so I moved it. I made it up for the left hand player, and S is down for the left hand side.
Okay.
Simply I is, yeah. So you can put whatever. Cool. Great. Okay. So I was imagining this will take us 2 help sessions, but we are speeding through this. So great. This is fun. So the only remaining thing we have to fix is this scanf, right? We don't want to block at this scanf. So we will have to use something else. And in particular, we'll have to use curses.h. And yeah, I don't use this very often, so I'll have to try this and see. So then we will have to. So this is like a library built to support building UI, right? So currently the terminal is buffered. So scanf waits for your input, but we don't want to wait for the input. So what we are going to do is use this library. And the way to use this library is initially we initialize the screen. Then when we end the game, we have to end the window. So again, like there is nothing deep here. This is just some functions I need to put for the library. So don't worry too much about what these functions are doing. And another reason is I myself have limited understanding, but basically it's for writing UI. So instead of scanf, we will say get character. And we will say So the logic is the same. The only thing we are doing is we are we don't want to block on the input. So let's see if this works. So instead of return, we also should change that. So instead of return 0, we should so because this library plays with the terminal, so it's best if we can call end win, otherwise the terminal gets messed up. So instead of return, let's do a break here so that we can call the end win function. Okay, let's see if this works. Oh my god. Okay, and another thing is instead of printf, we need to use printw to print on the window. So again, this is another library function, but the logic is the same, so let's not worry too much about it. Okay, and I missed something again. So we also have to do, instead of, so every time we print something, we have to refresh the screen. So we say clear, and then we say refresh. Okay, so now this is working. Oof, let's slow it down. Yeah. Right, so the library basically, I did too many things.
Excuse me, sir.
Sorry, yeah, say that again.
Sir, I think the ball is going above the top boundary. Can you see that?
No, it touches the boundary. So
Like, I think it is going up.
okay, so one thing I'll do is put the printf outside. So actually, let's just move this end win inside. Sorry, 1 second. We'll look at that, what you were mentioning. And let's break is fine. Yeah, I see it. Okay, so now this is printing player 2 wins. What did we do? So we are saying if it is less than equal to 0, okay, we can just make this 1. Similarly, we can make this -2. So this should be fine. Okay.
So we need to change on the top boundary, not the bottom boundary.
Sorry, say that again.
So we just needed to change the top boundary, not the bottom one, because now it is getting reflected from one above the bottom one.
No, I think the problem previously as well was we didn't like that it was, so on the boundary it is drawing dots, right? If the ball r is 0, it will draw a ball instead of a dot, right? Our draw grid function basically draws the ball wherever we ask it to draw. So if you put row size -1, it will again draw it on the ball, and we want it 1 before the ball. So that's why row size -2 is fine. Okay.
So can you say about the ncurses library once again? What changes you made?
Yeah, sure. Okay, now this will be okay, sure. So the changes I made are the following. First, I have to initialize a screen. So first of all, I have to include curses.h, right? This is a library that helps you draw UI. Then I have to initialize a screen, right? Then I will get back to non-block. So I initialize the screen. Then instead of scanf, I use this function called getCharacter.
There one thing. So this curses.h, where will we get it? Like we download it? It's not showing it in my terminal.
Which platform are you on?
Cygwin only.
Sorry?
Cygwin terminal.
Oh, Windows. Okay. This should be available. So I have not tried it on Windows. Let me reply it offline. I'll have to search on Windows.
Okay.
Maybe something is different. So yeah, the things I did was init screen. Then instead of printf, I have to change. So when I draw something to the screen, instead of printf, I use a print w. So this is saying print to window. And before this, I clear the screen. And after I'm done printing, I refresh the screen. So if you don't refresh, all your changes will not appear on the screen. And the other thing I did was when you end the program, you should use endWin. Otherwise, you are still in that window even after the program has ended. So the terminal will get messed up. Yeah.
Okay, sir. Thank you.
Cool. So yeah, great. I think this was quite a productive session today. We built an entire end-to-end game in like 75 minutes of our time. So this was fun. Any other thoughts, questions?
Sir, sir, can we make a player to play itself like the computer is performing the task for this?
Nice, good question. Yeah, so maybe we can do it in 15 minutes.
So the score implementation that like we are ending now, but say after 5 scores or something that.
Sorry,
I think so, like first to reach 5 wins.
We are ending at the first one, so score, like showing the score.
Yeah, how about you take it as a homework, right? You should, so I'll post this code. You should play with this and try to, so you can do a few things. So you can add a score, right? One thing. So here are a few things you can try, like, so let's call it. So this is again not graded, not part of the course or anything. It is just for fun. If you are busy, don't do it. But add score. So first to 5 points win, right? And show scores. So we should also show the score somewhere. So like in this one, this is showing the score somewhere, right? We should show that somewhere. Then another thing you can do is like angle is actually a little bit not that makes the game a little bit not that interesting. So what these, I was actually reading this. So what these guys did was, by the way, this game has a very interesting history. This game started the entire video game industry in 1972. So when people built this, then this was the first time they realized that, oh, you can actually earn money by selling games. So in a way, they started the video game industry. So another variation you can do is if it hits in the middle of the paddle, then it does like proper law of reflection. But if it hits like under the paddle, then it skews the angle a little bit. Or if it hits above the center point of the paddle, then it skews the angle in the other direction. So that also makes the game a bit more interesting. So as you can see this game, right? So in this game, the angle doesn't remain the same. Like depending on where it hits the paddle, the angle becomes different. So this is another thing you can try. Change angle depending on where it hits the paddle. Another thing to make the game interesting is ball keeps speeding up if the game goes for longer, right? So if there are two pro players which are really good, then they can kind of play this forever, but you don't want that. So you can keep trying to speed up the ball if the game goes on for longer. So maybe like every 1 minute the ball, or 10 seconds the ball is moving faster. So these are some variations you can try. And another variation is this smarter AI. So I'll write a dumb AI which will work, but you can think about how to do this smarter AI. So the AI problem is the following, right? So the field of AI has a lot of interesting, what to say, like intermingling with the games. Like initially, games is a very good way of studying AI. So because people used to believe like only intelligent beings can play games. And at some point it was believed like if a computer can beat the grandmaster in chess, then basically computer is smarter than humans, and that was considered like the best AI problem you can work on. But in like 1996, actually computer beat the best chess player, and then people changed the definition of what is a smart computer. But yeah, like building a automatic player for a game is a interesting, it's considered like AI problem. So we'll do a very simple variation of this. So let's say our paddle 2 is now 1 is now the computer. So we will stop controlling it from the keyboard, and we will do something very simple. So we'll say if ball R is greater than P2 R, then I'll just increment it. Else, if this is like a dumb AI, right? But it will work. So if ball R is less than P2R, then I decrement it. So what this is saying is if the ball is above the paddle, then I'll move the paddle up. If the ball is below the paddle, I'll move the paddle down. So actually, we also need to worry about the condition. So I'm going to say move paddle down P2R, 2, move paddle up and this paddle is now also taking the velocity with which it should go up. So this is, let's say, speed. So my PR is speed and this is speed. So my PR is speed, right? Okay, let's play this. This is.
Sir, can you explain the speed? I didn't understand why we needed speed, sir.
Yeah, so because it is dumb AI, like if we don't put speed, it will not work. So basically what it is doing is if the ball is above me, then I'll go up. If the ball is below me, I'll go down, right? It's a very basic AI. But the problem with this AI, if the ball and paddle are always moving with the same speed, then the paddle will never be able to catch the ball, right? So if the ball is moving up and I am also moving up in the same speed, I will not be able to catch the ball.
So sir, we have to make it faster than the ball
Exactly.
of the paddle.
Exactly. So we are cheating a little bit, and that's why this is a dumb AI. Like and we are cheating here. So like if the paddle is not allowed to move faster than the ball, which is actually the realistic scenario, then this AI will not work, right? Because I will never be able to catch the ball, right? So let's run this and see what happens, right? So this is moving. This keeps moving with the ball. If the ball is moving down, it is moving down. If the ball is, sorry, you cannot see what I'm pointing to, but shoot, sorry. But look at the pattern among the right paddle and the ball. And I'm also trying to, actually we can do computer versus computer. That is easier. So let's also make P1R follow the same logic. Right, so I am saying 6YY. Right, so they are both playing with the same logic.
Sir, even with the dumb AI, we will never be able to defeat it, right? So why are we calling it dumb?
Yeah, because we are breaking the rules of the game. So the rule of the game should be yeah, let's get back to that. Let's first make sure we understand this. Then we will discuss that. So now look at both the players, right? So they are always in sync. If the ball is moving down, I am moving down. If the ball is moving up, I am moving up. It's a very simple logic, and it will work, right? Good, great. So this works.
Sir, why are you calling it dumb?
Okay, so now the next question is, why are we calling it dumb? So the thing is, because like it's a bit of cheating, right? Like we made so imagine if you are competing with a proper, like with a human player, this game is able to move the paddle in with every frame, right? At a very high speed. It is moving at double the rate of the ball at every frame. Whereas your human is only able to move one step at every frame, and because their reflexes are slow or whatever, they will not be able to move as fast as the paddle. So generally speaking, to make the game more realistic, you should not make such assumptions like this kind of. So ideally, what should happen is the ball should move faster than the paddle, right? The computer should not be allowed to move the paddle this fast. Otherwise, the game is just like, think about all the games you play, right? Like, I don't know what is popular right now. Fortnite, I don't know. Counter Strike, whatever, right? Like, if the computer is moving super duper fast, then that game is like cheating, right? It's
Sir,
not.
is it like the computer is just moving faster than us?
Yeah,
it's doing that the same computation that we do faster than us, so it's
Sir,
beating
it's
us.
like the computer is printing the paddle wherever the ball is, so
Exactly.
it will never lose.
Right. So to make the game more realistic and fun, like so that the paddle also loses sometimes, you should make more realistic assumptions. So like here now I'm making the speed of the ball faster than the speed of the paddle. So as you can see, or I hope we'll see, is now it's not gonna be able to keep up, right? As you can see, right? So if the ball is above the pedal, it tries to catch it, but it is not going to catch it because the ball is faster. So a smarter AI would have been trying to, like in this case, it is going down for no reason, right? It could have predicted that the ball is going to reflect and come up. So I shouldn't be going down right now. I should go up, right?
Right, sir.
Right. So that would be a smarter AI, right? Than this one.
Sir, like I was checking, there is no ASCII character for the up and like arrow keys. So if we wanted to do it by the arrow keys, then how would we do it?
I think ncurses, this library has something. I don't remember. I think it's called key_down or something. We can try that out, but I don't remember. Let's try it. Let's see if this works. It doesn't work, right? Overflow converting case value to case value to. Yeah, but there is some keyword like this in this ncurses library that you can. Yeah. Okay, so to summarize, you can play with, I will share this code. So you can play with the following things, right? So add scores, show scores. So smarter AI has the following problems to solve. So first is paddle is moving slower than the ball, right? How do you solve it, right? So that is interesting. It's actually not that hard. It's a math problem. You can solve it. And then ball keeps changing angle. How to move paddle. So this AI is for this particular game variant. This particular game variant that depending on where it hits, you can change the angle of the ball. So how to build an AI for that? So cool. Yeah. Great.
Excuse me, sir.
Yeah.
Sir, what is the non-block function? Because it doesn't show it on my laptop.
Yeah. That was another cheating I did. So in for your so this is a thing I had to do for Mac, but for Linux, what you can do is hash include conio.h in this kind of angular brackets, right? And then in get ch, here you can do if keyboard hit. So only try to read a character if keyboard is hit.
Okay, sir. Then could you share the other header file, because I'm not on Linux, so.
Which one are you on?
No, I'm on macOS as well, so I wouldn't have that header file, right?
Okay. Yeah, sure.
Thank you, sir.
Yeah, but unfortunately, this curses is not very platform independent, so this is a bit of a pain. Yeah.
So for Windows, this curses is not showing up. Sir, will you like share it?
I don't have a Windows machine. How should I do this? Yeah, let me try to figure it out. How to do this.
I can download, like if it's available, and like sort of include the file, PDF file.
Yeah, let me Google around. So I don't know, but yeah, let me post it later.
So can you send the Mac code somewhere?
Yeah, I'll put this code. So this code will work on Mac. I'll put this one, but it may not work on other platforms. So everything else will work, just the curses bit may not work. Like you can still do scanf and play. So it's not that fun. Okay, great. Thanks for sticking around the whole session.
So on Thursday, what will we do? Like,
Sir, please upload this code.
Yeah. I'll upload it. Thursday, I'll post it. So I was thinking we will take 2 sessions to do this, but since we finished it in 1 session, we can do something else on Thursday. If
Sir,
there's
like,
any suggestions, I'm happy to.
sorry to interrupt, sir. Like, why does curses work only on Mac? Like, what is curses?
This is a library. So I think it has to do with how the terminal manages the buffer. So it's basically overriding the terminal functionality, right? So scanf, like the terminal buffers the user input, and when you press enter, only then it gives it to the program, right? But curses is basically overriding that and building its own window, building its own screen, and overriding the behavior. So since every terminal is implemented differently, I suppose, on different platforms.
So basically, like, it is a C library written for a Mac terminal.
It works on Linux as well. So Windows, I think it worked, but I'll have to check.
Okay.
Yeah.
Okay.
Cool. So yeah, like if you have any suggestions for the next time, happy to hear them. Like if you want to do something in particular, happy to like discuss that. Otherwise, I'll create my own agenda and talk about other things. Yeah.
Sir, we could try Minesweeper next time.
Yeah, so I think I would stick away from games a bit now since we have already done 1 game. We'll probably, yeah, I was thinking we can do COVID simulation, like how COVID is spreading. That is one. So we can, so games, I think you should be able to create other games now. I hope so. We can empower you in doing other things, like simulation is one, but yeah. So if you're interested in Minesweeper, build it yourself. I think you should be able to.
Sir, sir, can we do something like create a library with our own functions?
Um, so this is what I did here. So by not using Angular brackets, I used exclamation mark and sorry, not this double quotes, and in the same folder I have this .h file. So this is basically including this non-block function from the .h file that I defined. So the answer is yes. Yeah.
Okay.
Sir, can you
Okay.
please explain the like function of con.io.h and that end when?
Yeah.
So
So
sorry to ask. And
yeah, sure. So let's say we create a new thing called screen.c and include. So curses.h is, we needed it because we don't want to stop the game for taking the input, right? When we were using scanf, it was the ball would move 1 frame, then it will pause, wait for our input. When we give it the input, then the ball will move another frame. So we didn't want to do that, right? We wanted to keep moving the ball and not block on the input. So that's why we were using curses.h. So then your next question is, why do we need end win? So let's see what happens if we don't have end win. So let's say I clear, I print hello, and then I say refresh, and then I skip this end when, right? So we'll see what happens. And then instead of pong.c, I'm going to run scr.c. So it printed hello, right? And it returned back to terminal. But now my terminal is completely messed up, right? I'm inside. So I'm pressing enter right now. If I press ls and press enter, you didn't see me typing ls. So it's all completely messed up because I didn't end the window. So that's why this endwin is useful. Because you want to recover the terminal to the original state. So now if I run the same program, we should be in a better state. So now if I run this, oh, where is the hello? Okay, so it just ended the window. So we didn't see the hello, that is fine. But at least my terminal is not messed up, right? So it went inside that screen and then it came out.
All right. Thank you, sir.
Okay, great. Cool. I hope this was useful and I hope this was fun. This was a lot of fun for me. I'll see you on Thursday. So feel free to like ping me with what you would like to see on Thursday. Otherwise, I'll do some simulation. We'll see. Okay. Thanks, everyone.
Thank you, sir.
Thank you, sir.
Yeah.